Fine then, now it's time for question number 4. And question number 4 is something like this. The given graph shows variation with distance r from center of. So here is the given situation where we need to see. So this is the graph and the question says, now this graph represents or corresponds to the graph of what? So that's a question. Though a very straightforward, but a lovely because it has been made in the reverse order. So initially you could say something is constant and something varies curvilinearly after that. So in all probability, by the experience of the graph that we're handling with, this one, the curve is a rectangular hyperbola. So I think with this statement now you've already made a guess. And yes, the first option in itself would be correct because for a hollow uniformly charged sphere, or what we call as a shell which is uniformly charged, potential inside is constant and outside potential is inversely proportional to r. So the first option that I've encountered in itself is the correct one. The potential versus r, initially constant and then inversely proportional to r. So yes, for question number 4, option number 1 stands out to be the correct option. Fine then, it's time for question number 5. Question number 5, and the question is something like this. A particle is moving along a circular path with a constant speed of 10 meter per second. Okay, a circular path where the particle moves with this uniform speed. We need to calculate the magnitude of the change in velocity when it moves through an angle of 60 degrees around the center of the circle. So a very straightforward, nothing could be a better gift than this. So here, let's try to see how can we do that. Obviously, when the particle moves by an angle 60 degrees around the circle, the velocity vector would have also turned by an angle 60 degrees, right? And now we need to find the change in velocity, and this is the difference in vector. And yes, the magnitude is same, so I can straightforward write the change in velocity magnitude, that's going to be 2v sine theta by 2, which is 30 degrees, and that's pi by 6, and that straightforward comes out to be v. In other words, the magnitude of the change in velocity is itself equal to the magnitude of the given vector. And the magnitude of the given vector is 10 meter per second. So the correct option would be option number 1. Therefore, the correct option for question number 5 here comes out to be option number 1. Time to move to question number 6. The 6th question that has been brought from the topic of Bohr's hydrogen model from the given chapter Modern Physics. So this is an area which is quite an expected one, and we generally focus on these topics during the classroom discussion. Okay, so it says there is a hydrogen atom which is initially in the ground state, and that's excited by absorbing a photon of wavelength this much. So the atom is going to go in the excited state. We need to calculate the radius of the atom in the excited state in terms of Bohr's radius A0. So Bohr's radius A0, that's the radius of the first state. That's what we need to calculate here. And for the sake of calculation simplicity, there is a bonanza given to you, Hc, which is 12,500 electron volt angstrom. Though even if it's not given, we always recommend that student memorize the value of this product. That's going to simplify the calculation to a very great extent. All right, so now let's see. What I need to do is that let me just try to calculate the final energy. What is it going to be? So that's going to be minus of 13.6 electron volt is the original energy, the ground state energy, plus the energy that it has absorbed. So that's going to be 12,500 electron volt angstrom divided by 980. So this is not a very tough calculation, and when you do that, you get the value as minus 0.85 of electron volt. So now that's so simple, minus 0.85 electron volt. Every JEE Main preparing candidate knows this value, that's corresponding to the energy of N equals to 4. So yes, the atom has finally gone to N equals to 4. Therefore, the radius when you write, that's going to be 16 times A naught, because you know of the recent fact that R is directly proportional to N square. So yes, for this question number 6, option number 4 is going to be the correct option. Should we proceed to question number 7? Fine then.